Hi there, this is Vahid from VRF Education channel, and today I'm going to continue our discussion on how to do things in parallel in Qt framework. If by any chance you followed my channel and watched other videos about concurrent execution in Qt framework, you might already know that Qt provides a way to get result back from QtConcurrent framework methods, the class named QFuture. In addition to get result back using QFuture, we can also monitor the current state of concurrent execution by using QFutureWatcher. As the name implies, we can pass an instance of QFuture to this class and start monitoring. We can get informed about overall progress, or we can pause the executions or even resume the paused execution, and also we can cancel overall process. We don't need to continue the concurrent execution. All these things could be achieved using QFutureWatcher. So let's go to Qt Creator and see how we can make use of this class in order to monitor the concurrent execution in Qt framework. So let's start our journey in QFutureWatcher, and here I just create and designed the UI for time-saving things, and here I created the slots for all these buttons inside the CPP file. For the start, I'm gonna create a list of integer number as we did in previous sessions, and I'm gonna run a function on this list using map method. And we are not going to get into details to the map and MapReduce things, and just create a list of integer data, named it data list, and also let's include a couple of things here. Oops. QFutureWatcher, I'm sorry. QtConcurrent, and also QMessageBox. Maybe I need to show a message box, and for now nothing. And also I'm going to create a helper function named doubler here. This function is used in map in QtConcurrent in order to multiply all items inside a list by 2. So here I'm going to pass a data and multiply it by 2. That's it. And in the start button, I'm gonna do what? I'm gonna first clear all the items inside the data list, because I'm going to run it multiple times using the start button, and then I'm gonna append, for example, 1000 items inside the data list. And also, in order to mimic a lengthy operation, I'm gonna use qthread mslip function and use 20 milliseconds. For each execution, I need to sleep 20 milliseconds, and then after that, I'm gonna multiply data by 2. So here I'm gonna say auto result, it's a QFuture, equals to QtConcurrent. Let's run map method and say you should apply doubler function on the all items inside the data list concurrently. That's it. And here, instead of waiting for result, we did this something like this in previous session. Result.wait for finished, and after it's finished, we just can see the output. Let's do it and see the output, and then get back for the other matters. And here I'm gonna, 1000 items is good. That not that, data list, because map gonna update the data list in place. So let's run the application, and here after 2 seconds, approximately 2 seconds, instead of for example 20 seconds, we can get result. What does happen? Multiple definition of doubler. Oh, maybe I created another class. Let's add a 1 at the for the name. It's not a good idea, but for now it's the easiest way to handle the situation. because I created a doubler in another class in previous session, and this is a global method. So, oops, I forgot to change the program start point. It's QFuture Watcher test dialog. And here I'm going to create an instance of this class and run it. Okay, everything is just under control. If I press start, the UI blocked, and after about 2 seconds you can see we have a list that all items are even now. All items multiply by 2, so that's okay. Now I'm gonna use QFutureWatcher, and we did it before when we just talk about QtConcurrent run method. So let's at first create a QFutureWatcher here. QFutureWatcher. It's going to monitor a future of QFuture of int, and the name is watcher. And in the constructor, I'm going to say that, okay, connect. There's a couple of signals in QFuture that is very handy, and we can make use of them. The first one is finished. I'm going to say QFutureWatcher of int finished signal connected to a slot inside my QFutureWatcher test dialog, and I will create it very soon. Process finished. That's it. And then let's create this slot. Here I'm going to show a message box, Q message box information. The parent is this, and the title is process, for example. The body is finished. That's it. And after that, I'm gonna QtDebug data list. And here, instead of waiting for result to be finished and after that print it, I'm gonna say underline watcher. I'm gonna set this future for you, the result, and then I think it's void. The result is void, not int, because we want to update things in place. Okay, let's run the application. And when I press let's see, something went wrong. And let's clean the project and then run it one more time. Sometimes it happened and you need to clean the output and then run it one more time. So that's it. And if I press start, the UI won't freeze because I just using QFutureWatcher, and you can work with the other buttons. And after a couple of seconds, approximately 2 seconds, this message box appeared. And if I press OK, you can see again all the items appeared inside the output console. So let's now continue on our process. Here I want to get information about the current progress inside this QProgress bar. For this purpose, we can connect. This time, connect the progress changed, progress value changed, and here I'm gonna call the progress bar directly and passed it to set value slot. Q progress bar, set value. And there's a little tips here. Let's see the output, and then I'm gonna show you what that tip is. If I press start, you can see progress bar fill really fast till 97%, and after that, after 1 or 2 seconds, this message box appeared. Okay, and then we have these items in the output. So why did this happen? Progress range or progress value changed. It's going to show us the number of threads that finished their works. So here we have about 1,000 items to be done. So we should set the progress minimum maximum to 1,000, not just 100. Okay, let's run the application and see the output. No, I think it's not applied. Let's clean and run it one more time. Okay, I press run. As you can see, this time progress goes smoothly from 0 to 100%. And if I press it one more time, yeah, that's gonna okay, and that's it. That's okay. So what if I change the UI in a way, something like this? I'm going to get the number of items here, and let's add a spin box here and change the maximum to 99999, and then oops, no, this one. So that's it, and this is SPN data count, and then the default value is 1,000 as before. And when I press the start button, I'm gonna use the current value inside SPN data count dot value. So what if I change let's press start. Everything is okay. Yeah, we have 100 items here, and if I change it to, for example, 100 and 1,500, okay, and if I press start, after a couple of minutes, after a couple of seconds, we are not reaching the end or 100%, and we just get the result back or the finished message box a little bit after, because we are not monitoring from 1,000 to 1,500. So we need to specify the beginning and the minimum and maximum values for progress bar automatically. How we can do this? For this purpose, we can make use of another signal inside QFutureWatcher. Let's duplicate it, and this time I'm going to use progress range changed. And let's see what happened when we changed a range of progress. This time I'm going to assign it to a slot inside current dialog. Let's create a test slot. So, and I'm going to declare it here, void test. In here, I received 2 values, int m and int n. These are the ranges, minimum and maximum. And I'm going to just print it out. M and N. Each time I want to start the operation, M and N will be raised using QFutureWatcher. This is the minimum and maximum boundary for the process. Let's run the application. So here if I change it to, for example, 1600 and I press start, you can see it says the boundary is this value. And here again, we are not reaching 100%. So let's see how we can handle this. For this purpose, I'm gonna change this. So I'm gonna say go and assign this slot to progress bar set range. Also, we have a slot inside Q progress bar that we can set the value minimum and maximum for a progress bar using that slot. Now I'm going to get rid of this test slot and let's run the application one more time. So this time I'm going to choose 1500 and press start. So here you can see we easily reach 100%, and if I change it to, for example, 500, the progress failed quicker, and also we get from 0 to 100. So that's it, how we can set minimum and maximum for a progress bar using QFutureWatcher. Let's go and implement these buttons. Maybe sometimes we want to pause concurrent execution. For example, we want to do to other things, or end user wants to do other things and it wants to CPU be free for that purpose. Here in on pause button, I'm going to say underline watcher dot. We have a deprecated method named pause for this purpose, but it's deprecated from version 6, and Qt suggests to use suspend method. Here we have two other signals, suspended and suspending. So you can use these signals and connect it to a slot if you want to do something when concurrent execution getting suspend. So I'm just calling suspend method. And also for resume, we have another option named resume. And also there's a signal here named resumed, and you can get informed when concurrent execution getting resumed. And as you can guess, for canceling overall operation, there's a method named cancel, and also a signal related to this method named cancel. And also there's a couple of informational methods. Let's see, watcher.is. You can get information about the current state of QFutureWatcher using, or QFuture using this method. Is cancelled, is finished, is running, and you can call them whenever you want to get information in any part of the application if watcher is accessible. So, and also we have another signal named started. You can be informed when the concurrent execution started. So I'm not assigned this signal to a slot, but it's very handy. You can use it. Started. Yeah, this is the signal, and this is it. Let's run the application. Let's change it to, for example, 5000, and here I press start, I press pause, the operation paused, I press resume, the operation resumed, again pause, resumed, pause, resumed, and let's let it be finished. So this is one iteration that we paused it or resumed it during the execution. And also I'm gonna run it one more time. This time I'm gonna choose 1000, start. And here you can cancel the operation. When you cancel, the finished signal will be raised, okay? Will be emitted, and you can do what you want in the finished slot, and you should check if the process is finished or is cancelled. What does it mean? Here I'm going to say if underline watcher is finished, show this message, and also and for the other part, else if underline watcher is cancelled, I'm going to show another message. For example, cancelled. And there's a big difference between these two process type. So if I just start the application, you can see after it finished successfully, the finished message appeared. And if I start it one more time, press cancel, it, oops, again it says it's finished. Why? let's see. But I think we should change the order because the cancelled operation already is finished. So I'm gonna change this one. I'm gonna move it to the top, and let's first I check for cancellation, and after that I'm checking for finished. Using this approach, we can distinguish between cancellation and finished. Let's run the application. I think I should, let's do it. I'm going to start the operation and press cancel. Yeah, this time it's canceled. And I'm going to start it one more time and let it to be finished. Yeah, this time finished. That's it. So this is all about QFutureWatcher, and you can make use of it. Or if you want to, for example, show the progress without designing a dialog for yourself, you can use QProgress dialog. Let's do this. Here I'm gonna do what? I'm gonna create. Let's bring it QProgress dialog. This is the dialog that contains a progress bar and also cancel button. It's gonna show you the current progress that you provide for it, and also if user press the cancel button, it will inform you, and you can also cancel the operation. So here I'm gonna create an instance of let's create an instance here, QProgress bar dialog. I'm going to create a pointer, PRG dialog, and here I'm gonna say PRG dialog. Let's instantiate it from QProgress dialog and pass the parent, and let's do what? For PRG dialog, we have a method named setRange, and we need to provide minimum and maximum for that. For this purpose, I think we can let's do this here. Let's do what? I'm gonna duplicate it and say convert it, and here I'm gonna say DLG or PRG dialog and QProgress dialog. This time setRange method, and after that, and let's just cut this line and paste it here, because here we used it in the constructor, so we need to instantiate it. And in progress value changed, I'm going to duplicate it. Instead of setting value in UI progress bar, I'm going to choose PRG dialog, and here I'm going to say, okay, assign this signal to set value slot from QProgress dialog. And after that, yeah, that's okay. Let's run the application and see the output. So I'm going to change it, for example, to 2000 and press start. You can see this time a progress dialog with the cancel button appeared, and after the progress finished, it's disappeared automatically and finish button appeared. And let's see what we can do. PRG dialog that sets, for example, set label or set label text. We can sample thread, and that's it. Let's run it to see. Here we have a label on the top of the progress bar to get user informed about the current process. This sample thread, and you can also provide another information. And let's implement a slot for the cancel signal. I'm gonna say process, or I think we can connect these together. Connect from DLG or PRG dialog. The signal is cancelled and connected to underline watcher, and let's copy this, cancel. So that's it. I connect the cancel from QFuture, from QProgress dialog to the cancel slot inside the QFutureWatcher. So I'm going to change it to 2000 and press start. Here, if I press cancel, you can see signal connected to the slot and the canceled message appeared in the message box. So that's it. If you don't want to create a progress bar, you can use QProgress dialog in your application. So this is getting a little bit lengthy, and I hope you enjoy it. I try to tell the basic concepts about QFutureWatcher to you and how to control the concurrent execution in your application. Till next session, and talking about filter part of QtConcurrent, this part I mean, this part, the filtered and filter reduce. Goodbye.